Okay, so a little bit of a review here. The definition of a logarithm. Well, we know that if you have y equals b to the x, you can write that as log base b of y equals x. And we can go the other way. So we can write, if we have log base b of y equaling x, then that turns into, you take the base b and then come over here and get the exponent, b to the x equals, and then it equals the argument. So we did those in the section, I don't know which section it was, 6.3 I think, where we were converting from logarithm form and exponential form, and that still holds, so that's a review. We're going to use that now to solve an equation. Okay, so I have 2 natural log x plus 3 equals 7. First thing I'm going to do is subtract the 3, which you probably would have thought of that. So we're going to get the log by itself. Now you might be thinking, well, why didn't I use other techniques? Well, first of all, this is our first equation that we're solving with a logarithm in it. We used logarithms in other equations, but this time they gave us a logarithm. Okay, so we want to isolate the logarithm in this case. We're going to divide both sides by 2. And so we have the natural log of x equals 2. And now, how do we solve for x? How do we get that argument out of there? The only way to get the argument out is to change to exponential form. I shouldn't say the only way, but I only have one logarithm here, so it's the only way. So think of the base as being e because it's a natural log, and we're going to convert it then. E squared equals x. So the base, come over here, get the exponent, and it equals the argument. And now you've solved for x. X equals e squared. That's an exact answer. You could get a decimal approximation on a calculator.